Acha, let's read the question. A solid body, a solid body starts rotating about a stationary axis with an angular acceleration b is equals to b naught cos phi. That means the acceleration is given by some constant into cos phi. Okay, where this body was rotating about a stationary axis. Okay, and the angular acceleration beta is equals to b naught cos phi, where phi is the angular displacement. Okay, where p naught is a constant and phi is the angle of rotation. That means this phi is the angular displacement. Find the angular velocity of the body as a function of angle phi and draw the plot of this dependence. That means what is the question trying to say is find velocity, find angular velocity as a function of angular displacement, not as a function of time, but as a function of angular displacement. So how do we find that? We simply know angular acceleration is equals to omega d omega by d phi. Where does this formula come from? A is equals to v dv by ds. Okay, or angular acceleration into d phi is equals to omega into d omega. Okay, what is the value of angular acceleration? The value of angular acceleration is nothing but b naught cos phi. Okay, so if we substitute that out here, the value of angular acceleration is equals to b naught cos phi into d phi is equals to omega d omega. If we rewrite the equation, b naught cos phi is equals to omega d omega. Okay, acha, b naught cos phi, I made a mistake, little bit mistake out here. B naught cos phi into d phi, where this entire thing was the angular acceleration, d phi was nothing but this d phi went to the left hand side, is equals to omega d omega. Okay, b naught is a constant, no? So b naught into acha was the integration of cos phi d phi. Cos phi d phi is equals to omega d omega, or b naught, the integration of cos phi is nothing but sin phi. Since you are since I primarily solve all my questions with indefinite integral, even I'll do the same thing out here. Omega square by 2 plus some constant. Now in order to find out the value of constant, we must put a boundary condition. So what is the boundary condition? See, a solid body starts rotating about a stationary. Starts rotating means this term starts rotating. That means at phi is equals to 0, omega is equals to 0. Okay, so putting the boundary condition at angular displacement is equals to 0, our value of omega is equals to 0 into this equation. We get the value of constant. So applying boundary condition, b naught into sine 0 is equals to omega square by 2. What is the value of omega? 0 plus constant. So the value of constant out here is nothing but 0 because sine 0 is 0. So constant is equals to 0. So the value of this constant is equals to 0. So our main equation comes out to be b naught sine phi is equals to omega square by 2. Now if we take the 2 to the left hand side, what do we get? 2 b naught sine phi is equals to omega square. And what's the value of omega? Under root of 2 b naught sine phi is equals to omega. Now in the question, what you have to do is draw the plot of this dependence. That means you have to draw omega versus phi. And how does the graph look like? Now this was the equation of our angular velocity in terms of phi, or angular displacement. Now in order to draw this graph, or in order to draw the graph of omega versus phi, okay, just tell me, how does the graph of omega versus sine theta look like? Sine or theta look like? Okay, how does the graph of omega versus theta look like if omega is equals to sine theta? Okay, we'll learn the details in the chapter of functions in mathematics, but right now I'll just give you a little bit of brief. Okay, the omega was, if omega is equals to sine theta, the graph would look like somewhat like this. Okay, this is pi, this is 2 pi. Okay, now if I add 2b naught, omega is equals to 2b naught, what would happen? See, in case omega is equals to sine phi, the peak of this graph would be 1 and -1. Okay, if I add 2b naught out here, what would be the peak of this graph would change to, now the peak of this graph would be plus 2b naught and minus 2b naught. Well understood this one? Okay. Now what happens if I add under root to this one? Under root of 2b naught. What would happen is the curvature out here, of under root of 2b naught sine phi would be somewhat greater than this curvature, because this 2b naught sine phi can be lesser than 1. Okay, it goes like this and it comes out to be like this, it can go like this. Okay, so our main graph will look somewhat like a value of sine phi till pi. Understood? But the maximum peak value would be under root of 2 p naught when the value of phi is equals to pi by 2. Okay, when the value of pi is equals to pi by 2. Okay, now what happens for this negative part? What happens for this negative part? See, the negative part simply does not exist because under root of any negative is any imaginary number. So we cannot plot the imaginary number, no? So that's why after pi, the graph ceases to exist. In order to solve this question, we must first understand the concept of instantaneous axis of rotation. Okay, instantaneous axis of rotation. Now, for example, okay, there is certain motion which is a combination of rolling motion or rotating motion plus linear motion. Okay, a motion that is a combination of rotating motion plus a linear motion. Okay, one of the famous example of this kind of motion is rolling motion, where a wheel rolls over a surface on the road. Okay, this kind of motion is called rolling motion. Okay, so whenever there is a combination of rotating motion, okay, plus sliding motion or linear motion, in those kind of problems, what happens, this wheel, okay, will move forward plus it will roll, no? So there is an instantaneous axis of rotation. The instantaneous axis of rotation is defined as a point, is defined as a point through which the entire body can be assumed as rotating, through which the entire body can be assumed as rotating, can be assumed as rotating, or pure rotation, or purely rotational. Okay, purely rotational. Now, one of the conditions for instantaneous point of rotation is, or instantaneous axis of rotation is, the point through which the instantaneous axis of rotation passes, the velocity of that point would be zero. Velocity velocity of a point through which instantaneous axis of rotation instantaneous axis of rotation axis of rotation passes is zero. Okay, for example, in case of pure rolling motion, what is the instantaneous axis of rotation? This point out here, or this point moves towards the or away from the, not away, means perpendicular to the plane of rotation. So this point, the axis of rotation is inside the plane or perpendicular to the plane of the wheel or plane of the wheel. Okay, for pure rotate or for pure rolling motion, the velocity of this point would be zero. So this point for pure rolling is known as the instantaneous axis of rotation. Understood this concept? So this is the concept that must be known in order to solve this problem. Okay, now let's erase it. Now let's read the question. A rotating disc move in a positive direction of x-axis. Find the equation y is equals to x, describe the position of instantaneous axis of rotation if the moment of the axis of disk was located at point 0 at which it is moved. Okay, this point C was initially located at this point O, and this wheel moves in this direction in the x-axis. Okay, plus it rotates in this direction, and the question is asking us to find the instantaneous axis of rotation. That means find the point in this entire disk at which the velocity of that point is equals to 0. Okay, condition A, when the constant with a constant velocity v, that means this motion in this direction is with a constant velocity v, while the disk started rotating counterclockwise with a constant angular acceleration b. That means the disk is rotating in the counterclockwise direction with constant angular acceleration b. Okay, okay, so our initial condition for part A of the question, the disk is moving with velocity v and rotating counterclockwise with b. Okay, so if I take this motion, okay, if this is moving with velocity v plus this entire body, this entire body of the wheel is rotating counterclockwise with acceleration v with initial angular velocity 0. Okay, so at some point in this entire wheel, okay, at some point in this entire wheel there would be a velocity 0. The net velocity would be 0. See, if this point has a velocity v, okay, that means every point in this wheel is moving in this direction with velocity v. Okay, so every point in this wheel, okay, will move with velocity v in this direction. Okay, and if it is also rotating with angular acceleration in this direction, that means every point, okay, from the center will exhibit a rotational motion to this center. Okay, so velocity at this point would be how much? Suppose I'm taking this second problem. Okay, okay, this is the wheel. What is the velocity of this point due to rotation only? The velocity of this point would be in this direction. Okay, by how much magnitude? Let's say the distance from the center of this point is a. So the acceleration of this point, let the acceleration of this point be a, or the linear acceleration of this point is nothing but b into a. And how do we obtain that? There are three formulas. Okay, displacement is equals to theta cross r, velocity is equals to omega cross r, and acceleration is equals to how much? Beta, or angular acceleration, cross r. Okay, so any point in the wheel will translate effectively. So suppose this is the acceleration of this point. Suppose this is a distance b, not b, let's say c, from the center. The acceleration of this point would be in this direction, and the acceleration would be equals to beta into c. So the effective solution to our problem would be find a point in a wheel such that, suppose this is a point in the wheel which is at distance y. Okay, the translational velocity due to this component is v. Okay, and the rotational velocity due to the rotational would be some angular velocity into y. Okay, find this point which is y from the, or find this point which is y from the center such that the effective velocity is equals to 0. When is the effective velocity is equals to 0? When the value of omega y cancelled out the value of velocity v. Understood this position, or understood this much concept? Okay, now problem is angular acceleration is given, the angular velocity was not given, the angular acceleration was given. Now let's say at certain time t, at certain time t, okay, the distance x, or the position x from point O would be given as x is equals to how much? V into t. Okay, because there is no linear acceleration. Okay, and what is the angular acceleration, or what is the angular velocity? Angular velocity would be given by omega final, or omega is equals to omega initial plus beta into t. Okay, and what is the initial angular velocity? 0. How do I know that? See, if the initial moment, see, while the disk started rotating means the initial velocity is equals to 0 out here. Omega initial is equals to 0. Okay, so out here angular velocity is equals to b into t. This is our equation number 2. Okay, now somehow I have to substitute or eliminate the variable of t. So I can easily substitute t is equals to x by v. From equation 1 I get x by v is equals to t. I can substitute that in equation 2, or omega is equals to b into x by v, or the value of angular velocity is equals to b into x by v. So the value of omega is equals to b into x by v. Now our equation says that, okay, omega into y is equals to v. Why? Because this velocity must counteract omega into y, because the net effective velocity at the instantaneous axis of rotation should always be 0. So out here v is equals to omega into y, but omega is equals to bx by v, or if I solve this one, v is equals to bx by v y, or v square is equals to bxy, or v is equals to under root of bxy. Okay, oh sorry, I'm supposed to find out the value of y with respect to x, not b, or y is equals to v square by bx. Okay, this is the answer to our first question. I'm not required to find out the value of velocity. Okay, so y is equals to v square by bx. Y is equals to v square by x. Okay. Now the second part of the question. Okay, the disk is sliding with a constant acceleration w. See, in order to avoid confusion, let's make this variable constant acceleration a. That means the disk is moving with constant acceleration a. Okay, with zero initial velocity, while the disk rotates counterclockwise with constant angular velocity omega. That means the angular acceleration, sorry, the linear acceleration of the disk is a, whereas the angular acceleration in counterclockwise, sorry, angular velocity in the counterclockwise direction is equals to omega, and this angular velocity is equals to constant. And we must find the instantaneous axis of rotation. That means a point from the center at which the effective velocity becomes zero. Y at which effective velocity becomes zero. So out here, the acceleration due to linear component would be how much? Or the velocity due to linear component would be v is equals to u plus at, where u is equals to 0 because zero initial velocity. So v is equals to a into t, and the velocity due to rotational component would be omega into y. Okay, so at certain time t, at time t, okay, what's the velocity? Velocity is equals to u plus at, where u is equals to 0, or velocity is equals to a into t. But we must express our answer in terms of x. Okay, y must be expressed in terms of x. So how do we incorporate x? Can I say x is equals to ut plus half at square? Okay, this body or this point, see, started at this point O. So u is equals to, at time t is equals to 0. Okay, at initial time the initial velocity is equals to 0, or x, this value of x is equals to how much? Half half acceleration into t square. Now you must find the value of x. 2x by a under root is equals to t. So out here t is nothing but v is equals to how much? A into, what is the value of t that we obtained? 2x by a. Now this a can be written as under root of a into under root of a, and this a and this a would get cancelled to be root a, or v is equals to under root of 2ax. Fair and fine. Now the second part of the equation. Okay, what is the velocity due to this part? Velocity due to this part is equals to omega into y. Okay, and to find out the instantaneous axis of rotation, the velocity due to rotational, which is equals to omega into y, is equals to translational velocity, which is equals to a into t, where a into t is nothing but, or translational velocity is nothing but, we just obtained under root of 2ax. Okay, you obtain the translational velocity out here. Okay, or omega into y is equals to under root of 2ax. Okay, or y is equals to how much? Under root of 2ax by omega. Or I can rewrite the same equation as x is equals to y omega k whole square by 2a, or x is equals to omega square y square by 2a. Okay, I simply took this term to the left hand side, whole square both left hand side and right hand side, then divided by 2a. Okay, we get the value of x. But to really understand this question, you must first understand a concept called concept of pure rolling. concept of pure rolling. Okay. Acha. In the previous question, you have learned something about instantaneous axis of rotation. In concept of pure rolling, what happens is, suppose there is a car. Okay, there is a car moving on the road with v velocity per second, or 100 km per hour, or let's say 30 meter per second. Okay, 30 meter per second. Instead of making it 30 meter per second, let's say it v meter per second. Problem is, this car, the wheels of the car, are rolling over the road. Now, when you analyze these wheels, okay, we'll just analyze the motion of these wheels along the road. In pure rolling, what happens? The wheel does not slip on the road. That means this point, okay, this point does not slip on the road. It does pure rolling. Okay, so the velocity of this point is equals to 0. That means this is the instantaneous axis of rotation. Okay, one more thing to note is that if the car has velocity v for pure rolling motion, the center will always have the velocity v. Okay, v. The velocity at this point or point of contact is equals to 0. Okay. Now, as I said, so this is the instantaneous axis of rotation. Instantaneous axis of rotation for pure rolling. For pure rolling. Okay. That means no sliding. That means the wheel does not slide on the surface of the road. Now see, any type of rolling motion can be divided into two types. Okay, a combination of two motion. The first one is a rotating motion, and the second one is a translating motion. Okay, okay. So this rolling motion can be described as a combination of this rotating motion and this sliding motion, isn't it? Okay. Now suppose this was rotating with omega angular velocity and this was sliding with v angular velocity. Okay, okay. Now for the bottommost point to have zero velocity, okay, what should be the velocity at this point and what should the velocity at this point? Okay, the velocity at this point from sliding motion is v along this direction. Okay, and the velocity of this point due to rotating motion is omega r along this side. Okay, so can I say net velocity, which is equals to 0 for the bottommost part, is equals to v on the right hand side for sliding motion minus omega r due to rolling motion, v due to sliding motion, because whenever a body is sliding, all the points, each and every point on the body will have the same motion as the sliding motion. And whenever a body is rotating, okay, each and every point will have a combined, see, any point, suppose this point will have a velocity of omega r. Okay, this point will have a velocity of omega r, which will be normal to the radius, any point in the disk. Okay, this point, not only on the rim, this point also works on the inside of the disk, will have a velocity of omega r normal to the disk. Okay, so at the bottommost point, the v velocity is being balanced by omega r, which is equals to 0. So from this equation, 0 is equals to v minus omega r. 0 is equals to v minus omega r. Can I say v is equals to omega r? So for pure rolling, what can I say? For pure rolling, I can say the angular velocity of the wheel is equals to velocity divided by radius r. Now the question is, suppose take any more arbitrary point. Suppose take this arbitrary point, okay, which is let's take this arbitrary point, okay, which is distance a from the center of the wheel. Okay, what is the total velocity of this point? The total velocity of this point is a combination of translational velocity that comes from this component, which is equals to v, plus a rotational component. Rotational component comes from here, and rotational component will always act perpendicular to the radius, which is equals to omega into a. Okay, or distance from the center, omega r. Why? Because the rim is at radius r from the center. Okay, so the total velocity at this point is a vector combination of this vector omega a plus this velocity vector. Understood this much? Okay, so what would be the total velocity at this point, at the topmost point of the wheel? Let's take at the topmost point of the wheel. Okay, let's take the topmost point of the wheel. What is the velocity at this point? Velocity of this point is a combination of v from translational plus omega r. Okay, plus omega r. Now v is equals to omega r, which is valid only for pure rolling. Valid only for pure rolling. Acha. For pure rolling, what are the important facts that we must remember? The point of contact does not slide or skid. Okay, the instantaneous axis of rotation is the point of contact. Okay, and v is equals to omega r. Okay, yeah, valid. So v plus omega r, and omega r itself is equals to v for pure rolling. So this can be substituted by v. So the topmost point it moves with 2v. Okay. Similarly, any other point at this point, the total velocity of this point is a combination of omega r and v. Okay, which is equals to v root 2, because omega r is equals to v for pure rolling, which is equals to v root 2 in this direction. Okay, this is the concept of pure rolling that you must to understand. Okay, now let's look at the question. A point A located on a rim of the wheel of radius 0.5 meters, which rolls on a slipping along a horizontal surface with velocity 1 meter per second. That means this is a surface, okay, and a wheel, okay, wheel of radius how much? Radius 0.5 meter, 0.5 meter, rolls in such a way that the velocity is equals to 1 meter per second. Okay, the first part of the question is find the modulus and direction of acceleration vector of point A. Acha. What is point A? The point A is located on the rim of the wheel. Okay. So take any point A. Okay. Let's take this point A. Okay. So the velocity of this point A and the acceleration of this point A can be a combination of two velocities. Okay. A velocity, rotational velocity plus translational velocity. Because any rolling motion, respective pure rolling or not, okay, is a combination of two velocities. A rolling motion, sorry, a rolling motion, okay, with omega plus a sliding motion with velocity v. Now let's take this point A. Okay, this point A due to sliding motion will have velocity v. The point A will have velocity v due to sliding motion. Acha. Is there any sliding acceleration? This velocity is constant, no? So the acceleration due to translational component is equals to 0. Okay. Now for the rotational component. Okay. For the rotational component, point A was out here. What is the velocity of this point A? I know that velocity of this point is 0. Velocity or of this point due to rotational component is omega r. Okay. Velocity of this point A is equals to omega r in this direction. Okay, and all these angles are normal to the radius. Okay, now for pure rolling, what is the condition? For translational, the component of velocity is equals to v. For pure rolling, this v was equals to omega r. Why? Because the net effective velocity at the bottommost part should be equals to 0. Okay, so out here, the net effective velocity at point A is a combination of v and omega r in this direction. Okay, and what is the acceleration of this point? See, in circular motion, there are two types of acceleration. One is tangential acceleration. Since the omega is not increasing or decreasing, that means omega is constant. If omega is constant, that means this body will move with continuous uniform velocity. Okay, so the tangential component of this acceleration is constant or zero. Okay, now for this body to move in a circular orbit, or this point to move in a circular orbit, there must be another component of acceleration, and that component of acceleration is called centripetal acceleration. Okay, there should be a centripetal acceleration. See, the only acceleration present out here. Is there any acceleration due to translational component? No. Is there any acceleration along this direction due to this rotational component? No. There is only one component of acceleration that is directed towards the center, and that is centripetal acceleration. And the value of centripetal acceleration is equals to v square by r. Okay, or is equals to omega square r. Now note one more thing. This v square is not the effective total velocity or the combination of these two vectors. This v is not the combination of these two vectors. This v is only the rotational component of this vector. Understood? Why? Because there is only a centripetal acceleration occurs only from rotational component. Okay. Okay. So what is v square or what is omega square? See, from this relation, from the condition of rolls without slipping, that means pure rolling, I get v is equals to omega r. Okay, or omega is equals to v by r. Okay, so omega is equals to v by r. A centripetal part of the acceleration is equals to omega square r, omega square r, or v by r whole square into r, which will automatically come as v square by r, or is equals to v square by r. What is v? V is nothing but 1 meter per second, or 1 square by what is r? 0.5, which is equals to 2 meter per second square. So the acceleration, total acceleration, which is only the centripetal acceleration, which is always directed towards the center of the wheel, is 2 meter per second square. Okay, now let's look at the second part of the question. The total distance traveled by the point A between two successive motion when it touches the surface. That means what the question is trying to say is, suppose this was the road, okay, and the wheel started out here. This was point P. It rotated an entire rotation and reached point or place out here. Okay, this is again point P. Find the distance traveled. Now some of you might think the distance is 2 pi r. Okay, 2 pi r is the displacement of point P. The actual point P would have moved somewhat like this. When the wheel rotated out here, or when the wheel went forward, the P point moved little bit upward. Okay, so the actual motion of path P would look somewhat like this. Okay, and the question is saying find the length of this path. Now problem is, how do I find out the length of this path? I can easily say this is 2 pi r from elementary math, but how do I find out this path? See, in kinematics we can simply use one of the relation. Okay, speed dot dt, or integration of speed with time, would give us distance. Okay, we know this formula. Problem is, how do I find out the speed? Okay, I have the displacement, but how do I find out speed? Okay. One more important factor you have to note out here is instantaneous speed. I think the spelling is wrong. Is equals to instantaneous velocity. So that means you have to make use of these 2 points. Integration of speed with time is equals to distance, and instantaneous speed is equals to instantaneous velocity. What I'm trying to do is I'm trying to select this point P. Okay, then I'm trying to find the speed of this particle or instantaneous speed of this particle, not average, instantaneous. Okay, at every point, the speed of this particle at this point would be 0, or the total velocity vector along this point would be 0. Then as it reaches out here, the speed would be something else. Okay, the combination of magnitude of this vector plus this vector. When the particle is out here, it will be a combination of this vector or translation vector plus omega r vector. Okay, so if I find out the magnitude of velocity vector at each of these point and respectively integrate with the time or with in dt, I'll get the entire distance. Okay, but what are the variables that I can integrate with? Say I have theta out here. Okay, theta. Okay, so this point move out here. Suppose at some point p. Okay, after some time t, theta moved out here. Okay, now how much is theta? See, at the starting of rotation, the point P was out here. After some time, the point moved out here, or point moved distance theta. See out here. Omega was equals to constant. There is no angular acceleration. So is there a relation between theta and t? Of course, theta is equals to omega initial t plus half alpha t square. Since there is no angular acceleration, this entire component becomes 0. Or theta is equals to omega t. Theta is equals to omega t. Okay, so the angle theta is equals to omega t. Okay, now this velocity is equals to omega r from rotational component. This velocity is equals to omega r from rotational component, and this velocity is equals to v from translational component. This velocity is equals to v from translational component. Okay, and let us make this point A, or when the P reached point A, or when this particle reached out here at point A. Okay, after rolling. Okay, when this particle reached at point A, see one more thing, there might be a misrepresentation in the diagram. This wheel would have moved little bit forward. That means the wheel would pin out here. Okay, and the point A would be out here and the wheel would be out here. So don't ask me how the wheel moved backwards or how this point A move backwards. Okay, so somehow I have to find the total vector summation of this vector and this vector. And to find out this is the summation of this vector, I have to find out this angle. Okay, now let's check this. This. Okay, this angle is theta. Okay, this angle is theta. Okay, now see what is the angle between this vector and this vector. Can I draw a straight line out here? I can draw a straight line out here. I can draw a straight line out here. The angle made by this angle and this radius is 90 degrees. Okay, so watch out. And this was the direction of omega r. Okay, this was the direction of omega r. What is the angle between this and this line? This line and this line are always 90 degree. This line and this line are always 90 degree. 90 degree. Let me draw a straight line. Okay, this is a right angle triangle. Why? Because this is vertical, this is horizontal. So this is 90 degree. If this is 90 degree, how much is this? This is 90 minus theta, because sum of angles of a triangle are always 180. So this is 90 minus theta, or theta dash. And this line and this line are parallel. So if this can be velocity vector, this entire velocity vector can be shifted out here for the ease of calculation. So the angle between this vector and this vector is nothing but 90 plus theta dash, or 90 plus theta dash, 90 plus theta dash. What is theta dash? In my representation or in my notation, theta dash is nothing but 90 minus theta. So the total angle is 90 plus 90 minus theta, or is equals to 180 minus theta. So the total angle out here is 180 minus theta. 180 minus. Okay. Now this theta can also be written as omega t. Okay. Why? Because angular acceleration is equals to 0. Theta is equals to omega t. So I can write the net summation is equals to, or velocity resultant velocity at point A is equals to v square plus omega r square. Acha, let me write one more thing, or let me deduce one more thing. What is the value of this omega r? For pure rolling, the value of omega r is equals to v. For pure rolling, v is equals to omega r. Okay, so plus omega r square plus 2 into v into omega r into cos of 180 minus omega t. Okay, what did I just do out here? I just applied vector law of addition, or parallelogram of vector law of addition. Okay, there are two vectors, first vector, second vector, a square plus b square plus 2ab cos of angle between them. Okay, or magnitude of vector, or magnitude of resultant vector is equals to v square. Omega r can be written as v for pure rolling. So if I substitute omega r as v square plus 2v square cos of 180 minus omega t. Cos of 180 minus omega t. Okay. Now in trigonometry, there is a formula. Okay. Cos of 180 minus theta, or cos of 180 minus any angle, is a minus of cos of that angle. Cos of 180 minus theta is equals to minus of cos theta. Okay. So can I just simply substitute this entire thing by minus of cos omega t? Of course. So minus of cos omega t, minus cos omega t. Okay, minus of cos omega t. Can this minus go forward, or can this minus move out here? Minus into plus is nothing but minus. So I'm substituting this plus as minus. Okay, so v square plus v square, is nothing but 2v square. So this is nothing but 2v square. Okay, so 2v square minus 2v square cos omega t is nothing but 2v square 1 minus cos omega t. I'm taking 2v square common, so 2v square 1 minus cos omega t, 1 minus cos omega t. Okay, now in trigonometry there is another formula of cos theta. Cos theta can be written as cos theta by 2 plus theta by 2. Okay, and cos a plus b can be written as cos a cos b, or cos square theta by 2 minus sin a sin b, or sin square theta by 2. So this cos omega t can be written as how much? Cos omega t can be written as cos square omega t by 2 minus sine square omega t by 2. Okay, so I'm substituting this entire thing cos square omega t by 2 and sine square omega t by 2 out here into cos square omega t by 2 minus sine square omega t by 2. Okay, I'm rubbing this all. Now this entire thing becomes 1 minus cos square omega t. If I remove the bracket, what will happen? Minus cos square omega t, and this minus into this minus will become plus. So plus sine square omega t. And out here it would be this one if I remove the bracket. Okay, I remove the bracket out here. Okay. Now in mathematics there is another formula. Sine square theta plus cos square theta is equals to 1. Or I can simply write cos square theta is equals to 1 minus sine square theta. Okay, so can I substitute cos square omega t as 1 minus sine square omega t by 2? Okay, so I'm substituting that value out here. 1 minus 1 minus sine square omega t by 2. Okay, I'm rubbing out the rest. Now if I remove the bracket, this becomes 1 minus 1 plus, if I remove this bracket, this become 1 minus 1 plus sine square omega t by 2, and this bracket gets removed. Okay, so 1 minus 1 is 0. Okay, plus sine square omega t by 2 and plus sine square omega t by 2 becomes 2 sine square omega t by 2. So this becomes 2 sine square omega t by 2. Okay, 2 and 2 gets multiplied, or this entire thing becomes the resultant is equals to 4v square sine square omega t by 2 under root. Okay, or is equals to 2v sine omega t by 2. So the resultant velocity at any point is given by v resultant, or v resultant, or speed at any point is given by 2v sine omega t by 2. Okay, this is the important thing that we need to remember. The speed at any point is given by 2v sine omega t by 2, or 2v sine theta by 2, but theta is equals to omega t. So the value of constant becomes 4v by omega, or constant is equals to 4v by omega. Now when you put the value of this constant in this equation, okay, what do I get? I get this constant is equals to 4v by omega. Okay, now the thing is, okay, our equation of distance becomes distance is equals to minus 4v by omega cos omega t by 2 plus, what is the value of constant? The value of constant was nothing but 4v by omega. See, in the previous slide I did value of constant is equals to 4v by omega. Okay, is equals to distance. Now question is, at what distance I need to find out the value of omega t by 2? The value of omega t by 2 after one complete rotation should be, theta should be 2 pi for one complete rotation. This must be 2 pi r, no? This entire length of straight line should be 2 pi r. So the wheel must have rotated by 2 pi angle. Okay, so theta must be 2 pi. If theta is 2 pi, omega t is equals to 2 pi. So we need to find out the distance at 2 pi. Distance at omega t is equals to 2 pi. So I substitute the value of 2 pi out here. Minus 4b by omega into cos. What is the value of omega t? 2 pi by 2 plus 4b by omega. Okay, pi. Value of cos pi is nothing but minus 1, or distance is equals to minus of minus 4v by omega plus 4v by omega is equals to 8v by omega, and for pure rolling v is equals to omega r, or v by omega is equals to r, or is equals to 8 into v by omega, or 8 r. So the distance traveled, or the length of this entire path, is equals to 8 r. Okay, the length of this entire path is equals to 8 r. What I actually did out here was I calculated the instantaneous velocity, and I told that instantaneous velocity is always equals to instantaneous speed for any type of rotation, and then I integrated the entire instantaneous speed with the entire period of motion, and I got out the entire distance. Understood? Okay, so now let's read this question. A ball of radius r is equals to 10 centimeter rolls without slipping. That means the instantaneous axis of rotation is at the point of contact. That means this is the instantaneous axis of rotation, and the velocity of this point will always be zero whenever this condition is maintained. Okay, that means this is a case of pure rolling. Pure rolling. And in case of pure rolling, the velocity of point of contact is always equals to zero. At an inclined plane, so that its center moves with constant acceleration. See, let us change the variable of acceleration as a in order to avoid confusion. Okay, at t is equals to 0 after the beginning of motion, find the velocities of point A, B, and O, the acceleration of this point. See, what the question is saying is that this body is performing a pure rolling motion. Okay, and pure rolling motion is nothing but a combination of rotation and translation. Okay, now for pure rolling, the condition is the total velocity at this point. The total velocity at this point should always be equals to 0. So whatever be the velocity, instantaneous velocity at any time, should be equals to omega r. So the linear velocity of this point should always be balanced by omega r of this point. So v is always equals to omega r for pure rolling motion. Okay, for r is the radius of the circle. Okay. Now it is given that this point has an acceleration of how much? 2.5 centimeter per second, but it has some acceleration. Okay, so see one thing out here. If this point has acceleration, that means the velocity is going to increase. If the velocity is going to increase, this parameter of velocity is going to increase. Okay, and rolls without slipping. That means at all time, the net effective, or at any instant point of time, the net effective velocity at this point should be equals to 0. So whatever is the velocity out here, that should be the velocity out here. So can I say at any instant v is equals to omega r? Now this v is not constant, so dv by dt should be equals to d omega r by dt. Okay, now the radius of the circle is always a constant. This value of radius will always remains a constant, no? So dv by dt is equals to r d omega by dt. What is dv by dt? Is nothing but acceleration. What is d omega by dt? Is nothing but angular acceleration. So I have said that what I have effectively proved out here is that the tangential acceleration, okay, out here will always be equals to the rotational acceleration out here. Or I have simply proved this relation. The acceleration out here is equals to r alpha for pure rolling motion. Okay, So let me erase this one. So I have done what is tangential acceleration of the bottommost point is equals to angular acceleration into r. So this linear acceleration will cause an angular acceleration out here. Okay. Now the question is saying after t is equals to 2 seconds. Okay. From the beginning of the motion, the velocity is at point A, B, and O. So after 2 seconds, what is the acceleration? So what is the velocity after 2 seconds? We can simply apply v is equals to u plus at. Initial velocity is equals to 0. Why? Because a ball of radius r rolls without slipping at an inclined plane with constant acceleration. After the beginning of motion means initial velocity is equals to 0. Okay, so v is equals to a into t. V is equals to a into t. So the velocity at bottommost point would be at this side. So at point O, after 2 seconds at point O, okay, at point O, the velocity due to translation would be equals to at, and whatever is the velocity of translation will be balanced by the velocity of rotation in opposite direction, which is equals to at. Okay, so is equals to, see, similarly you can write omega is equals to omega initial plus alpha into t. Okay, omega initial is equals to 0 because at the beginning of motion, omega initial is equals to 0. So omega after 2 seconds will be equals to alpha t. So v is equals to at. Okay, out here v is equals to, or omega into r, or alpha into t into r. Okay, so the velocity at point O is always equals to 0. This much is understood. Acha. From this equation, can I deduce a relation between alpha and a? Of course, I can deduce. See, you can simply write alpha t r is equals to a into t. Okay, t and t will get cancelled, or a is equals to alpha r. So we have already derived that, and v is equals to omega r. Okay, so now let's read this question. A ball of radius r is equals to 10 centimeter rolls without slipping. That means the instantaneous axis of rotation is at the point of contact. That means this is the instantaneous axis of rotation, and the velocity of this point will always be 0 whenever this condition is maintained. Okay, that means this is a case of pure rolling. Pure rolling. And in case of pure rolling, the velocity of point of contact is always equals to 0 at an inclined plane, so that its center moves with constant acceleration. See, let us change the variable of acceleration as a in order to avoid confusion. Okay, at t is equals to 0 after the beginning of motion, find the velocities of point A, B, and O, the acceleration of this point. See, what the question is saying is that this body is performing a pure rolling motion. Okay, and pure rolling motion is nothing but a combination of rotation and translation. Okay, now for pure rolling, the condition is the total velocity at this point. The total velocity at this point should always be equals to 0. So whatever be the velocity, instantaneous velocity at any time, should be equals to omega r. So the linear velocity of this point should always be balanced by omega r of this point. So v is always equals to omega r for pure rolling motion. Okay, where r is the radius of the circle. Okay. Now it is given that this point has an acceleration of how much? 2.5 centimeter per second, but it has some acceleration. Okay, so see one thing out here. If this point has acceleration, that means the velocity is going to increase. If the velocity is going to increase, this parameter of velocity is going to increase. Okay, and rolls without slipping. That means at all time, the net effective or at any instant point of time, the net effective velocity at this point should be equals to 0. So whatever is the velocity out here, that should be the velocity out here. So can I say at any instant v is equals to omega r? Now this v is not constant, so dv by dt should be equals to d omega r by dt. Okay, now the radius of the circle is always a constant. This value of radius will always remains a constant, no? So dv by dt is equals to r d omega by dt. What is dv by dt? Is nothing but acceleration. What is d omega by dt? Is nothing but angular acceleration. So I have said that what I have effectively proved out here is that the tangential acceleration, okay, out here will always be equals to the rotational acceleration out here, or I have simply proved this relation. The acceleration out here is equals to r alpha for pure rolling motion. Okay, so let me erase this one. So I have done what is tangential acceleration of the bottommost point is equals to angular acceleration into r. So this linear acceleration will cause an angular acceleration out here. Okay, now the question is saying after t is equals to 2 seconds, okay, from the beginning of the motion, the velocity is at point A, B, and O. So after 2 seconds, what is the acceleration? So what is the velocity after 2 seconds? We can simply apply v is equals to u plus at. Initial velocity is equals to 0. Why? Because a ball of radius r rolls without slipping at an inclined plane with constant acceleration. After the beginning of motion means initial velocity is equals to 0. Okay, so v is equals to a into t. V is equals to a into t. So the velocity at bottommost point would be at this side. So at point O, after 2 seconds at point O, okay, at point O, the velocity due to translation would be equals to at, and whatever is the velocity of translation will be balanced by the velocity of rotation in opposite direction, which is equals to at. Okay, so is equals to, see, similarly you can write omega is equals to omega initial plus alpha into t. Okay, omega initial is equals to 0 because at the beginning of motion, omega initial is equals to 0. So omega after 2 seconds will be equals to alpha t. So v is equals to at. Okay, out here v is equals to or omega into r or alpha into t into r. Okay, so the velocity at point O is always equals to 0. This much is understood. Acha. From this equation, can I deduce a relation between alpha and A? Of course, I can deduce. See, you can simply write alpha t r is equals to A into t. Okay, t and t will get cancelled, or A is equals to alpha r. So we have already derived that, and v is equals to omega r. Similarly, at point B, okay, at point B, the velocity due to translational component would be equals to at. The velocity due to rotational component would be equals to omega into r, which is equals to alpha into t into r, which should be equals to, where omega is equals to v by r, or v is equals to omega r, or omega is equals to v by r, or v by r into r, which is equals to v. Okay, which is equals to a into t. So at point B, due to translational component, the velocity is a into t. Due to rotational component, which is equals to omega into r or alpha tr, which is equals to same value of a into t. And this happens only in case of pure rolling. Okay, So the net effective would be 80 whole square plus 80 whole square under root, which should be equals to, if I solve this one, this would be this would give us the value of 80 into root 2. Okay, so velocity at point B is equals to a into t into root 2. Velocity at point O is equals to 0, velocity at point B is equals to this, and the effective direction of the velocity would be in this direction, or 45-degree angle with the horizontal. Why? Because both this vertical and the horizontal component has the same magnitude. What is the value of A? The value of A is 2.5. The value of T is how much? 2. Or velocity at point B is equals to 2.5 into 2 is nothing but 5 root 2 meter per second. Similarly, the velocity at point A would be at due to the translational component and omega into r due to rotational component, and omega r is nothing but alpha t into r, which is nothing but a into t only because of pure rolling. So velocity at the topmost component or topmost part A would be how much? A into t due to translational part and a into t due to rotational part. So total velocity is equals to 280, where a is equals to 2.5, okay, t is equals to 2, or total velocity is equals to how much? 5 into 2 into 2, which is equals to 10 centimeter per second. Achha, in the previous slide I made a mistake. Instead of meter per second, write it as 10 meter per, sorry, centimeter per second. Okay. Now we come to the second part of the question, the acceleration of these 3 points. Okay. So let's start with the bottommost part, the acceleration at point O. Due to translation, the acceleration would be equals to A. Due to rotation, the acceleration would be equals to alpha into r, where alpha is itself a by r, because in previous part of the question you already derived alpha is equals to ar. See, you already derived this one. A is equals to alpha into r. Okay, so if we combine this all, so due to rotational component, the value of acceleration due to rotation will also be equals to a. Now whenever a body is rotating, there is another acceleration that is called the centripetal acceleration, and the centripetal acceleration is given by v square by r, and v is nothing but a into t. Why? V is equals to u plus at, and u was equals to 0. Okay, so out here centripetal part of the acceleration is nothing but at whole square by r. So the total acceleration of point A is the vector summation of these 3 vectors, a and a square t square by r. So a and a would get cancelled, and the total acceleration is nothing but a square t square by r. Okay, I've used the variable a as acceleration, where irodov has used w as acceleration, so don't go get confused in the answer. Okay, so we now focus on the acceleration of part B. Okay, for part B, due to translational component of acceleration, it has a value of a. The rotational component of acceleration has a value of alpha into r, which is equals to a. Okay, for pure rolling, and for rolling motion or for rotating motion, there is another component of acceleration, which is a centripetal acceleration, which is equals to v square by r. Okay, and v square out here is nothing but a square t square by r. So total acceleration at point B would be equals to vector summation of all these 3 vectors, a square t square by r. If we add these 3 vectors, or a total would be equals to a minus a square t square by r whole square plus a square under root. Okay, I'm just finding out the magnitude of these 3 vectors. But a total, if I substitute all the values out here, I would get around 2.5 centimeter per second square. Just substitute the value of a as 2.5 and t as 2. Now to find out the acceleration at the topmost part, point A. Okay, the acceleration due to translational component is equals to a. The acceleration due to rotational component is equals to alpha into r, which is also equals to a. And there is a centrifugal part of the acceleration. Okay, which is equals to v square by r, or a square t square by r. So total acceleration at point A is equals to 2a in this direction, a plus a, and a square t square by r in this direction. So total component of acceleration is equals to, or magnitude of total acceleration is equals to 2a whole square plus a square t square by r whole square. Okay, or a total is equals to, if I take 2a common out here, okay, or if I take 2a common out here, I'll get 1 plus a t square by 2r, okay, whole square, okay, and 2a square under root. Or total acceleration is equals to how much? I can take this 2a outside, 1 plus a t square by 2r whole square. If I put out the values out here, I'll get approximately 5.6 centimeter per second square. Okay, so this is the end of question 1.5.